All right. Thanks everyone for joining the stream today. Excited to be talking to you about WhyLabs, how we can help you in a lot of different areas in your ML stack. Today, specifically focusing on data quality and data drift. Just a bit of housekeeping. If you have a question, we will be taking questions at the end, but feel free to throw it into the comment section. And I'll be taking them as I see them. If I don't get to them right away, I'll make sure that we spend some time at the end and go through the questions that you might have. If it's particularly a longer topic, maybe we could do some follow up and go deeper into the particular topic. But we'll go ahead and get started for the sake of time. So like I mentioned, today we're going to be focusing on how we can use WhyLabs to understand our data and understand our models a little bit better. Today we're going to be focusing primarily on data. So specifically data quality and data drift. We'll be talking about why we should be doing it, why it's important, what makes it particularly difficult for a lot of folks today, how we can do it. So, getting a little bit more tactical and some common approaches as far as measuring quality or measuring drift. And then we'll end our conversation with how we can use WhyLabs to help us to do this at scale and the overall workflow that goes along with that. At the end of the presentation, we'll leave some time, like I said, for Q&A. And if there's any particular topics that you want to talk about, please feel free to throw them into the chat. So a little bit about me, Andre Elizondo. I'm a principal solutions architect here at WhyLabs. I help folks on their MLOps journey, specifically with observability and implementing a visible model or visible data pipeline into production. I'm based in Seattle, Washington, and a little bit about that photo there. That was the biggest avocado I've ever found, and I was particularly proud of it. That photo will live on. I also put a little bit of a little coffee emoji there because I'm a huge fan of coffee, obviously being in Seattle. If you have a specific coffee method in mind that you take your coffee, please feel free to throw it into chat. Would love to know about what kind of coffee you particularly like. So to start off the conversation, why should we monitor for data quality? There's a number of different reasons from a technical perspective, but purely from a business and cost perspective, bad quality data tends to be expensive. Not only expensive from the perspective of maybe introduced failures or hard to find problems, but also expensive because of the amount of time that's typically wasted. One of the particular surveys here, there's some more information at the link below that I'll share later, is in a recent survey from Forrester, over 40% of data scientists that were surveyed spent almost half of their time trying to get their data into a point where it was considered good quality and also continually maintain it into that point. The other thing to call out is that bad quality data tends to also be very unpredictable. Because data is so important in a lot of our infrastructure and a lot of our stacks, it's important to get it right because the things that are consuming our data downstream, whether that's a machine learning model or just a data intensive application, that can typically create an unpredictable scenario for those downstream consumers. And so we want to make sure that our data is constantly high quality and constantly what those downstream consumers expect. And on the other side, why should we not only monitor for data quality, but also data drift? This tends to be a bit more of a complex topic. The reason why we want to look at data drift is oftentimes upstream data can change. So what our model or what our application might be consuming may have been a particular shape or particular distribution at the point of training or at the point of building. But then over time, either that's the upstream data sources or internal data sources, or even the team that maintains it, the schema of that data and the distribution of that data can change over time. And so it's important to be able to understand how much it's changed because oftentimes a drifted data set can also have very unexpected outcomes. So not only bad quality data, but drifted data may mean that, for instance, your machine learning model may not be able to accommodate that data drift. And maybe it prompts you to train your model again to be able to accommodate that better. But it's really important for us to have that level of visibility so that we know when that data drift has occurred. And why is it challenging? Why are we talking about it? For the majority of organizations, especially the folks that we talk to here at WhyLabs, for identifying data quality and data drift, this tends to be a process that's done ad hoc. It's not on a continual basis. So maybe at the point of training your model, you're doing a lot of data analysis and looking for quality of your data at the point of training or at the point of just ad hoc investigation. But it's not a continual process. And so that becomes a challenge once those models get into production. Getting that visibility long term becomes typically a more challenging task. And because of that, oftentimes this is mainly driven off of tribal knowledge of what that data should look like. So for a lot of organizations, the concept of drift typically means that somebody's looking at the data and making a human decision on how much that data is drifted or whether it's in a good state for your model. And that tends to be not a very scalable approach. The other thing is data tends to be very complex, either from the cardinality perspective or just from the amount of upstream data sources that need to be either transformed or reformatted. And typically also the size of the data tends to also be challenging to deal with for a lot of organizations. Once you get into terabytes of data, it might be more challenging to individually inspect individual rows of your data set to be able to identify drift. That tends to be a problem that maybe is very compute intensive to do. And a lot of the existing tools either will tell you to sample a lot, or you might just sample from a human perspective and just do a bit of a spot analysis, which is also very challenging to maintain and understanding if you're actually looking at the right things in your data. The last thing is drift and quality may be impacted by seasonality. Your drift may be, the way that you expect it for the point in time that you're at. You may see a particular higher level of drift, or particularly a higher level of quality problems around certain times of the year, and you might want a specific higher granularity view into those quality or drift problems, depending on how your business looks at the seasonality aspect of that. So from a data quality perspective, obviously you can't improve something unless you measure it. And so the first thing is obviously figuring out how we even determine whether data is good quality or not. So the first step typically in identifying whether your data is good quality is by defining clear metrics or internal standards for what does quality mean to you and your organization. For very high, very sensitive applications downstream, the ratio of data or the ratio of data to errors may be something that is particularly interesting to you. The number of null values or empty values in your data set may be an example of that internal metric. Or maybe like how often or how successful is your data pipeline in actually transforming and producing your data. Those are just three examples, but typically from a data quality perspective, you might be looking at things like volume, you might be looking at things like the freshness of the data, the fact that the schema is in the way that you expect it to, right? You're not getting every once in a while you get a string when typically you're expecting a bunch of integers or floats. Also looking at things like the distribution, which typically is related to drift. And then also understanding, for instance, from a data quality perspective, what's going to be impacted by that metric failing. So when it comes to understanding this internally, these are often the first 5 things to consider from an organization perspective on how are you going to understand if your data is quality and what happens if that data quality indicator is violated. What happens? What's the downstream impact there? And then on the data drift side, as far as understanding what drift means, this can be different for different types of organizations or different types of use cases. For instance, you may care about data drift from the perspective of, hey, I expect it to kind of look the same over the last 7 days, or at least a continual trailing window. Or in the case of a machine learning model, you may care about this data looking relatively similar to the data that you train the model in the beginning, right? So the different methods of identifying drift will typically depend on ultimately what type of outcome you're looking for. And whether that's defining a point in time where it's a reference, a specific point in time, or even a reference time range where you know that your model or your data should kind of look the same in the future based on a good known maybe set of days. And then also understanding how you're going to identify that data drift from an algorithm perspective. This is different for whether you're looking at it from a point in time perspective. You want to identify two specific distributions, maybe within a notebook, or you want to look at this at scale, maybe across multiple different versions of your model, where you're looking at different levels of cardinality or different levels of volume in the data set. Choosing the right algorithm can also ensure that you're not generating a bunch of noise, and that the drift that you identify actually has a meaningful outcome for you. So we talked about why we should look for quality in drift specifically. And we talked about some methods for identifying data quality indicators, specific metrics for when we know our data is quality. And then we also talked about how we can identify drift and different methods for identifying drift. And we specifically weren't going to go through it on this particular webinar. But if you'd like to know more on how WhyLabs looks at those different methods and how we can enable you to do this successfully, I would definitely recommend reaching out, scheduling some more time with us, and understanding how we can help you there from a variety of different perspectives. So how do we use WhyLabs, the platform here, and what we're here to talk about, to do this at scale, right? Look for quality and look for drift in our data at scale. Well, it tends to come down to these five particular things here that we're going to talk about next. So for instance, one is as far as a data quality perspective, we want to be able to ensure that we not only are understanding what our data looks like, but if we have particular things that we expect our data to look like, we want to be able to define that as code. There's different words for this across the industry, but at the end of the day, you want to just have some level of expectation on what should your data look like, either when it's coming into your pipeline, when it's being transformed, before it hits your model, when it's being passed in through Airflow or something like that. You also want to be able to look at your data over time. So not only a point in time when maybe you're training or you're doing an ad hoc investigation, but being able to look at overall trends. And then also being able to do that at scale. So looking for some of those indicators that we talked about, but at a higher scale, and being able to do this in production effectively without a ton of overhead. And then the other things we'll talk about is how we can use segments, for instance, to understand our data and our quality problems and our drift problems a little bit more fine grained, to understand where specific problems are occurring. And then we'll also look at how we can start using feature weights in the case where our data set is being used for a machine learning model, and we know, for instance, what does that model really care about, so we can prioritize our time on the most important features to our model. So we'll go through these points individually and talk about how WhyLabs can help you on a small scale as well as at a big scale here. So if you're not super familiar with WhyLabs, the platform, and what we're doing here from an architecture perspective, I'll spend just a second here, so I won't go into this super in depth. But we primarily operate on two main components. We have WhyLogs, which is our open source library. It's our method for collecting information, statistical profiles about the data. And then we use WhyLabs, which is our SaaS platform that helps to aggregate those profiles for a variety of different models, variety of different data pipelines into a single spot, and look for overall trends and highlight things to you that are important, as well as integrate with your notification systems, generate the right dashboards that your executive team or maybe yourself are using to gauge the success of your models and your data pipelines in production, and even potentially trigger different workflows downstream. So we won't go into this super in depth, but I'll highlight where WhyLogs and WhyLabs can be jointly successful in helping us to monitor for quality and drift at scale here. So we'll go ahead and go into the first topic. So how does WhyLabs help us to define and validate constraints on our data? So first off, the important thing here is to know that if we have expectations in our data, there's not really a reason to wait until that causes a problem in production, right? If we see that we're seeing data quality problems early on, there's not really a reason to not catch that as early on in the process as possible. So constraints is a really good way. It's built into YLogs, which is our collection method, to be able to define those kind of data contracts or data expectations in our data and be able to continually use that to validate what's going kind of in and out of my pipeline and maybe into my model downstream. So we can use YLogs to define those constraints. We will build a profile of the data set, whether that's a pandas data set, if it's or data frame rather, if it's a Spark data frame, or even just a Python dictionary, Java hash or map rather. Um, we can pass that into YLogs and generate that profile and then define those constraints on top of it. So it's a really good way and really fast way to be able to understand overall how is my data coming in or the data that I'm looking at meeting my expectations here or meeting my constraints. Um, and we'll generate, for instance, different reports here. We can do this using the library. We can generate these reports as artifacts. So if you're doing this as part of a pipeline, whichever pipeline methodology you're using here, you might be using DAGs in Apache Airflow. You might be using something like GitHub Actions. You can generate these constraints reports and use them as artifacts for the execution there. And again, measure them over time so you understand, for instance, how is your data matching up to the quality expectations that you've defined as code here. And just looking at that briefly here, we'll go ahead and jump into a quick example and do a bit of a live demo. So in this case, I'm defining a quick pandas data frame and I'm defining some expectations. So for instance, here I'm adding some constraints that say I expect my weight column to have a greater number than 0.14. I'm expecting the mean of that column to be above 5 and below, or sorry, above 2 and below 3. I'm expecting the number to be smaller than 20 and a few other constraints here that I won't go into individually, but I build that into a constraints builder and then I can run that against my profile. So I can use that to generate that report that I was talking about where now I can see, for instance, how is my data stacking up to those expectations or those constraints that I've defined as code. And then I can continually look at that as I'm continually using this data, maybe transforming it from upstream providers, checking different points in my pipeline to ensure the transformations happen in a way that I expected them to. And I can do this for a lot of different things, not just numerical. I can also do this for text data. I can do this for a bunch of different things because of the way that YLogs will profile that data and generate those statistical representations. All right. So besides that, now we've kind of looked at how we can generate constraints on our data set to look for data quality specifically. Now, in order to define those constraints, we profiled our data using YLogs. And those profiles are great when it comes to ad hoc exploration, right? I can profile my data set. I can look at it and, for instance, understand like, what does my data set look like? Is it kind of the typical bell curve that I would expect here? I can even compare, for instance, two particular data sets and see like a point in time comparison here and maybe check this against a particular algorithm that I'm using internally that works for me for validating drift between two particular points in time. But typically when I'm going to a point of scale, it might not be the same team or the same person that is doing this workflow here in a notebook to the workflow of validating this in production. So obviously it becomes a different problem to just be able to aggregate that data at scale. So this is where using YLabs, we can continually profile that data. So we're continually generating those statistical representations. I can look at a lot of those different factors here that can tell me about the state of my data set, whether it's high quality. I can, for instance, dive into a particular part of my data set here and understand a little bit further. But just understanding it over time and being able to understand trends becomes a different problem that you ultimately need a platform for, and WhyLabs can do that out of the box for you. The next thing we'll talk about is how we can use WhyLabs to not only aggregate the profiles of our data, but also identify problems in the data, right? So either drift problems or quality problems. This is where it becomes really valuable to have a platform that is looking at your data set, your profiles generated from that data set over time, because this is when we can start, for instance, highlighting particular issues here, right? Where we see not only at that point in time where you're validating in a notebook, how much drift am I seeing between those 2 points in time, but continually doing this and either validating it based on maybe a particular reference that you have of this was a good point in time that I know I want to continually validate against, or even a trailing window so I don't have to maintain those reference profiles. But this is how WhyLabs will continually look at those representations of my data and surface up those problems that maybe I need to be spending my time on. So either from a drift perspective, hey, in this particular case, the frequent items in my data set have suddenly shifted. So now I've introduced a drift of the over the threshold that I have defined here. Also, maybe I'm looking at a volume perspective, right? If I'm transforming data here, I want to ensure that the data coming in isn't just coming in or flatlining compared to what it was before, or maybe it's keeping within a particular trend that I expect my pipeline or my model to be processing or consuming. And then also looking for some of those things that we talked about on data quality indicators, things like missing value count. So am I seeing a ton of null values or even a ratio that's higher of null values than what I expect? Or even the cardinality, for instance, of my data set, which depending on what your downstream application of that data set is, may be very important to you to ensure that you're not just getting a bunch of cardinality drops in your data where maybe your upstream data source isn't producing as high cardinality data as you expect to be able to generate the right predictions. The last thing from a data quality perspective is highlighting things like mixed schema, where maybe your data has suddenly shifted from a fraction to a string to an integer to whatever. Being able to identify those shifts in the data set to understand how that schema is performing, especially if that becomes a mixed schema scenario where maybe those both exist at the same time and they're causing issues or unpredictability downstream. That becomes a really important issue to be able to identify early. All right, so how do we identify those problems? So coming back over to now I see a problem here, like how does WhyLabs help me to identify those problems? One of the things that we'll do is you can define inputs and outputs of your data set or of your model so we can correlate different aspects of that data set together. So for instance, here I can see that I have a drift in my delivery confidence, that's the output of my model. I can see that that generated an alert and WhyLabs was looking at that, and I'll talk about alerts in just a second here. But what I can do now is I can actually correlate it with the inputs that most likely generated this output anomaly. So not only are we looking at the anomalies or the problems from an individual feature, individual column perspective, but we can actually also correlate across the platform, which makes it a lot faster to identify those problems. Like I said, you probably also want to be able to identify when those things happen, that maybe it triggers a response flow on your side, or you're tracking, maybe you have a service level objective for your data pipeline or for your application or model that's consuming this. So ensuring that you have the right level of monitoring so you have a good gauge of how things are going makes it so that you're not just having to live in a platform or live in a console to be able to identify problems. And WhyLabs makes that really easy. You can click through, or we have some advanced ways to generate these models, or these monitors rather, but really easy to get started. And we can, for instance, get started with a couple clicks here, start sending that into maybe Slack or PagerDuty or an email. I can also choose whether I'm going to do that trailing window
Hey, Andre,
check here.
sorry to interrupt, but you're still just showing the slide, not that product.
Thanks. All right, hopefully that's coming through now. But now I can see, for instance, where I'm using the monitoring in WhyLabs to be able to identify those issues and surface them up to the right teams at the right time. All right, so coming back over, we'll go ahead and go through a couple more examples here. So now we've identified problems with quality. how do I use WhyLabs to understand where those problems in quality are occurring? This is where we can, for instance, start using segmentation in the platform. So I can come over and say, I want to go ahead and see how my different groupings of my data set are performing overall. So am I seeing an anomaly in a particular part of my data set that I'm not seeing in the other part? Is there particular bias in my predictions or bias in my inputs? Maybe I'm not sampling my upstream data set effectively to serve the right customers that my predictions are creating here. I can group those out and then have greater visibility. The last thing we'll go ahead and go through is I can also use things like explainability data. So I can come over and see, how is the model downstream going to be looking at my data set here? And which ones do I need to particularly focus my time on if I see maybe a higher alert count than others, so that I can really focus my time on the most important features or the most important problems in quality and or drift in my data set versus getting caught up in any kind of noise or delay in finding the root cause there. So just a few things that WhyLabs can help us to do here. So as far as like what we were able to talk about today, we talked about like why you should be monitoring for data quality and data drift. We talked about how we can do that tactically, and then we also talked a little bit about how WhyLabs can help us. And I would love to recommend anybody to reach out and schedule some more time and see how we can help you to do this at scale in your organization. But I would also leave a couple minutes here. Just if anybody has any questions, please feel free to throw them into the chat, and would love to just hear one, maybe if you have a question about how WhyLabs accomplishes what I showed you here, or if you have a method that's that you're using internally that's working for you, would love to also hear a little bit about how you're doing these things today. All right. I don't see any other comments coming in or questions coming in. So for the sake of time, please feel free to reach out if anything does pop in your mind based on what we were going through today. But as far as where we go from here, so some of the examples on docs.ylabs.ai, we have some good examples there for measuring quality or drift using Ylabs. There's also different notebooks and different examples for how you can do that. You can also go ahead and get started with Ylabs really quick and easy using our self-starter tier, ylabs.ai/free. I would highly recommend you join our Slack community, and if possible, give us a star on GitHub and check out the library there, Ylogs. So appreciate everybody taking the time, and we'll go ahead and end the stream.